Hello, this is Michael Kraut with Idea Dudes, and we're going to be talking about understanding routing.
The unauthorized reproduction or distribution of this copyrighted work is illegal. Criminal copyright infringement, including infringement without monetary gain, is investigated by the FBI and is punishable by up to 5 years in federal prison and a fine of $250,000.
So if you have any questions or comments, you can put them in the GoGo box at the bottom of the video. Let's get started. So in the module topics, we're going to look at routing tables. Routing tables are where the information is going to be stored. It's a database. We're going to be looking at IP routing protocols such as RIP version 2 and OSPF. We'll also be looking at multicasting. Hey, have you ever watched a movie online? That's multicasting. And VPN overview. So routing tables aid routing decisions by identifying the network interface cards within the inner network. And really, it boils down to, we got a bunch of NICs out there, and they have addresses, which they have IP addresses, and what it's doing is keeping track of where they are located. And so what it does is it allows us to be able to find the fastest route, which is known as the cheapest route, the cost. So it's a database, and the database keeps track of those network interface cards and where they're located with IP addresses. And the table consists of routes, which are entries within the routing table, contain information on where the network IDs of the inner network are located. And the inner network is just your network. And it may exist on hosts, which is the client computers. Remember, we have the DNS cache. We have a router cache also, which we do route print, and what that will do is that will display the database of the router. So the types of routing table entries, we have the network route, which is a route to a specific network ID, and then the host route, which is a route to the internet network address, custom routes to specific hosts, and then our default. This is used when no other route in the routing table are found. Now, if you look at the routing table structure, what we have is a network ID, the forwarding address, the interface, and the matrix. Now, the metric is the cost, or how much time is, what is going to be the actual price for using this route. So these are the information fields: the network ID, which is the network ID or inter-network address of the host route. The forwarding address, the address which the packet is going to be going to. The interface, which is the NIC that is used when the packets are forwarded to the network ID. And then the metrics is the preference. Lowest is the most preferred route. So what you do is, if you have ISDN, for example, you make that like 100, where a DSL, maybe 50. T1, then we go down to 30. OC3, now we're getting there. And that would probably be 1. So IP routing protocols, RIP for IP. This is RIP version 1, RIP version 2. Simple to configure and to deploy, and inability to scale to large or very large networks. OSPF, which is Open Shores Path First, designed for large and very large networks. Very little overhead. Complexity is the biggest advantage or disadvantage, and uses a map instead of a routing table entries. What it uses is actually it uses a linked state database. Now, multicast forwarding, TCP/IP performs multicasting forwarding functions. Receives and processes all multicast traffic, forwards multicast packets to appropriate interfaces. So when you're watching that movie, that's what's going on. Interfaces running IGMP, it places a network adapters in multicast promiscuous mode. That means you can capture traffic on the other side. Tracks multicast group membership. So devices that are part of the group will be able to watch the movie. And updates to the TCP/IP multicast forwarding table. Now, what you have is you have something called a heartbeat. And a heartbeat is making sure that the thing is alive. So multicast boundaries and a heartbeat Multicast boundary is administrative barriers. So we just set up, hey, this is an area, this is for this multicast, and this is for this multicast, and so forth. A range of IP addresses, multicast scope, and then a scope-based boundaries prevent the forwarding of IP multicast traffic to a specific group of IP addresses or range of IP addresses. We're saying, okay, we have a movie playing, but we don't want you to watch it. Now, when you look at the boundaries, we also have the time to live or TTL-based boundaries. And they prevent the forwarding of IP multicast traffic with a TTL less than a specified value. And the multicast heartbeat listens for regular notifications to a specified group address to verify the multicast connectivity. So it's making sure that the device is alive. Then we have network address translation, which we talked about before. A home or small office network. You share a single connection to the internet and consists of a translation component, which translates support numbers, such as 25 for SNMTP for your email. POP3 for collecting your email. Point-to-point tunneling protocol, 1723. RDP, 3389. 1434 for SQL Server. 20 and 21 for FTP. 23 for Telnet. 995 for Secure POP3. Addressing component, IP configuration information for other computers on the network. It's a simplified DHCP server. And name resolution component, which is the DNS substitute. Then we have the internet private addresses. And what these are addresses that are going to be, sort of IP addresses that are going to be used for internal use only. IANA provides the private network IDs, 10.0.0.0 with a subnet mask of 16 bits or 255.0.0.0. We also have 172.16.0.0 with a subnet mask of 255.255.0.0. That's a 16-bit subnet mask. And a 192.168.0.0 with a subnet mask of 24 bits or 255.255.255.0. So those are our internal, and we use those all the time. A lot of times if you go and look at your Linksys router, when you type in ipconfig and you're connected to that Linksys router, it's probably 192.168.1.1 is the actual default gateway that you're using. Guess what? That's pointing to your router, and that's what subnet you're on. Now, we have the ability of connecting to routes on demand, and that's what on-demand dial routing is. It's very complex and consists of a connection endpoint addressing, analog phone lines, and a phone number of the other identifier. Authentication and authorization of the caller, which we can use IAS for that, which that's a radius server. And authentication based on the caller credentials. So that way, what will happen is when it dials out, it will look to make sure it is the correct phone number. So it's not just dialing up a random number. Differentiate between a remote access and routers. RAS must identify the caller based on the username and credentials and must match the demand dialer. Configuration of both ends of the connection, even configuration on both sides of the connection. And then configuration of static routes. Static entries must be added to the routing table. It doesn't use routing remote RIP version 2 or OSPF. When you're dealing with demand dial routing, you actually have to use a static route. So next we talk about router-to-router VPN connections. And what a router-router is, VPN, it just makes it so it's a secure connection between two routers. Includes components of virtual private network clients. Client is the router, which is routing remote access 2003 or 2000. VPN servers are connections to the calling router, which is the answering router. LAN and remote access protocols. You have LAN protocols are used to transport the information, TCP/IP. And then tunneling protocols, we can use either PPTP or L2TP. Preferred for security, though, is L2TP. Now, demand dial interfaces can be used in a router-to-router VPN connection. The host name or the IP address of the VPN server, and PPTP port-to-port L2TP port. User account credentials and L2TP IPsec and a valid certificate. That's what you need for L2TP and IPsec. User accounts are created for calling routers and static routes or routing protocols. We can use like RIP version 2. Security options utilize all security features of the Windows Server 2003 family. Now, when you look at point-to-point tunneling protocol, this is actually one of the first VPN type protocols we've had. We've had it with NT, we've had it with Windows 2000, now Windows 2003, it's still here. Point-to-point tunneling protocol. Extension of PPP, which is point-to-point protocol. And is installed with TCP/IP. And routing remote access by default has 128 ports. What we can do is we can control how many ports, and we can put up like 5 ports if we want. Now, PPTP Primary Services. You can see we have the IP header, a GRE header, a PPP header, and an encrypted payload. And then we have the encryption, which is a PP frame. So encapsulation, what it does is it encapsulates the PPP packet. IP datagram is wrapped with a generic routing encapsulation and IP header. So you can see right here. Source and destination. And the primary services, you have encryption. So you have an encrypted payload. And PPP framework is encrypted by Microsoft point-to-point encryption. So this is a proprietary encryption algorithm from Microsoft. And MS-CHAP, which is Challenge Handshake Application Protocol, and EAP-TLS. Those are the 2 that can be used. PPTP does not provide encryption, but encapsulates a previously encrypted PPP frame. So what it does is it wraps it around it. Now, L2TP, on the other hand, is an industry standard tunneling protocol. It uses PPP, authentication, compression, and does not use MPPE. What it uses is IPsec. Now, it uses IPsec. Both L2TP and IPsec must be supported by the routers and installed with TCP/IP. And routing and remote access, we can support 128 ports. Now, when you look at the L2TP services, it's a little bit more complicated than what it is with PPTP. You have 2 layers of encapsulation. L2TP encapsulation, you have the PP frame is wrapped with the L2TP header and a UDP header. IPsec encapsulation, L2TP messages wrapped with the IPsec ESP header and the trailer, as you can see here. Now the encryption, L2TP messages is encrypted with DES and triple DES, or triple DES, encryption using IPsec authentication process. Now, we can do a dial-up router to a router VPN connection. This is used when you have permanent connection is not available or practical. So this is when you would use a T1 and frame relay. Do you have any questions? Use the question comment box. Thanks for joining us.